Hello everyone. I know this is a little bit late for a live. I've been pretty busy tonight, so I considered not doing it, but my grade 11 class has a quiz tomorrow, so let's do this. This isn't going to take too long. We're just going to go over how to solve mixed circuits. So these are the laws we're going to need. We're going to need Ohm's law, which is V equals IR. And then we're going to need Kirchhoff's laws and the rules for resistance for series and parallel circuits. So just to go over some of these Kirchhoff's laws, let's look at this circuit and then we'll solve another one. So here we have V1, so this resistor is 36 volts. And then we have an unknown current. And then we have over here, these two resistors have a current of 2 amps and 4 amps. Those we both know. So if we look at parallel circuits, we know that in a parallel circuit, the current actually adds. So what happened was this current that was coming from the battery split into two sections. I know my arrows are going in the opposite way because I'm showing electron flow instead of conventional current, but it doesn't really matter, right? So it splits into 2 amps and 4 amps. Therefore, I1 must have originally been 6 amps because they add. Now notice we know what V3 is. Therefore, for a parallel circuit, because these two resistors are in parallel, and in a parallel circuit, we have that all of these voltages are the same. V2 is also going to be 20 volts. Okay, let's move on, see if we can fill in everything else. So our current here comes back together here to be again 6 amps, and then it splits again into 5 and therefore 1 amp. Now both of these voltages we don't know, but we do know that they're the same because voltages are the same in a parallel circuit. Now the total voltage was 72 volts. So let's follow this. If we have an electron moving here, over here it loses 36 volts. And then it chooses one of these paths. Whichever path it chooses, it's going to lose 20 volts. So now we've lost a total of 56 volts. And as we go this way, whichever path it chooses, it must lose the amount of voltage equal to what it gained at the source. So if we've lost a total of 56, we need to lose another 16 volts. And it doesn't matter which path it takes, that's what we're going to lose. So that's our quick review. So let's go over and let's solve a circuit here. Here we go. So in this circuit, says, oh, I always forget to do that. Okay, so in this circuit, it says we have a battery with 20 volts. So this is 20 volts. And then every resistor is 10 ohms. So 10, 10, 10, 10, 10. And we need to fill in this chart. Basically, we need to figure out what everything is that is missing. So to do that, we are going to make this mixed circuit into a little bit more of a simple circuit. So notice that R2 and R3 are connected in series. Now for a series circuit, those resistances are just going to add. So we can simplify this by replacing R2 and R3 with one resistor. And we can do the same for R4 and R5. So let me just redraw that here. Just going to do a 1-cell battery instead. So here we have R1, and that's going to be replaced with this one and this one. Now this is still a mixed circuit, but that's all right. So we have, this is still 10 ohms, but here we have 10 ohms plus 10 ohms. So this one is 20 ohms. And these two are both 10 ohms as well, so they add to 20 ohms. Now, like I said, this is still a mixed circuit. So to make it a simple circuit, we can take these two resistors and connect them to form one equivalent resistance. And when we do that, we will have, well, this one is 10 ohms. That doesn't change. And then we will replace these with one resistor. So that leaves us with a simple series circuit that we can solve. So to add these, we have to add resistors. Kind of covered it up a bit, but let's go write this over here. So we're going to have 1 over R, let's do R parallel, going to equal 1 over 20 ohms plus 1 over 20 ohms. So that's 2 over 20, which is a fraction that reduces to 1 over 10. So we get 1 over R parallel is equal to 1 over 10. Now don't leave it like this. The resistance is not 0.1 ohms, right? We've only solved for 1 over R parallel. So what we need to do is take the reciprocal of both sides of that equation, and we get R parallel equal to 10 ohms. So this is also going to be 10 ohms. So now we can figure out what that total resistance is, because we have two resistors in series. Since it's in series, those are just going to add. So we get a total resistance of 20 ohms. And we know the voltage is 20 volts. And that's going to be the same for both of these. So let's not worry about the complicated mixed circuit. Let's look at this very simple one, because we can solve that. So here we have our total is 20 ohms, and here we have 20 volts. Okay, so we can figure out what that current is using Ohm's law. Anytime you have two pieces of information, we can use Ohm's law to solve for the third. So here we're going to have current. Sorry, that was just my daughter there. So we're going to have current equal to voltage over resistance. So voltage over resistance, 20 over 20, this works out nice. So we have current equal to 1 amp. Okay, and that's going to be the same for here. So here we're going to have 20 ohms, and here 1 amp. All right, so let's go figure out what these two resistors are. Now, this is a simple series circuit. In a simple series circuit, we know that the current is going to be the same throughout. So if we have 1 amp here, this resistor is 1 amp, and this resistor is 1 amp. And now that we have two pieces of information, we can simply solve for the third. Okay, so V equals IR. We do current times resistance. So 1 times 10, so we've got 10 volts and 10 volts. And we can do a quick check on this, because we know at the source we have 20 volts, and in a series circuit, these are going to all add. So if they all add, we have 10 volts plus 10 volts, and that equals 20. So we're doing okay so far. Now let's jump back and figure out how to solve this circuit. Okay, so in this circuit, we already know what this is. It's 10 volts and 1 amp. Okay, now over here, what we did was we took this parallel circuit and condensed it to one equivalent resistor. So to expand it again into parallel, we need to figure out, well, what's equal in a parallel circuit. And in a parallel circuit, our voltages are equal. So if 10 volts is going through this, then it's also going through both of these. So that's 10 volts and 10 volts. And then two pieces of information, we can use Ohm's law to figure out the third. Okay, so current is going to be voltage over resistance. So we have 10 over 20 ohms. So that's 1/2 amp. And I always encourage my students to leave things in fractions when we're doing a circuit analysis. And then over here, we have 10 over 20. So the same, 1/2 amp. And that makes sense, because here you have 1 amp and it splits in two where both resistors are equal resistance. So it splits equally in two, into 1/2 and 1/2. Okay, now we can go and solve everything over here. So we know R1, right? R1 we solved back here. So we have, it's 10 ohms, that's in the question, and 1 amp and 10 volts. So 1 amp and 10 volts. We know our totals, right? Our total resistance is 20 ohms. And where's our current? 1 amp. So we need to find R2, R4, R3, and R5. Okay, so R2 and R3, we condensed into this equivalent resistor. And we did that based on the fact that R2 is in series with R3. So in series, is voltage or current the same? And it turns out current is. So the current that goes through this resistor will be the same as the current that goes through both of these. And that is 1/2 of an amp. So this will have 1/2 an amp going through it. This will have 1/2 an amp going through it. And we know the resistances are each 10 ohms. So 10 ohms and 10 ohms. And then to figure out voltage, once again, if you have two pieces of information, you can use Ohm's law to figure out the third. So 1/2 times 10 is 5 volts. And same here, 5 volts. And this is a very nice symmetric problem. We're going to have the same thing for R4 and R5 because there's our current. So we've got 1/2 amp, 1/2 amp with each 10 ohm resistor, and using Ohm's law, we multiply them and we get 5 volts and 5 volts. And we can perform a nice check. So let's follow the current. So here we have the current, right? We've got a current of 1 amp. So through here, 1 amp, and then it splits into two. Now notice here we have 1/2 an amp on the top branch and 1/2 an amp on the bottom branch. So those do add to 1 amp. So our current laws are satisfied. What about our voltage laws? So we have 20 volts here. We lose 10 volts here. Now let's say we choose the top path, or our electron chooses the top path. It's going to lose 5 volts here, 5 here, and then come back to the battery. If it chooses the bottom half, same thing, 5 and 5, which is a total of 10 plus 5 and 5 is 20 volts. Okay, so you can fill in the chart. Everything I wrote up here instead of on the chart. I have a tendency of doing that. But if you have any questions, let me know in the comments. That was a short live because it's late. But to anyone who's writing a circuit quiz coming up, including my students, good luck. And I guess that's it. Good night, everyone.